What's up guys, welcome back to the next video on learning C++ STL. My name is QDS Dani and you guys watching my channel Cryowood. Alright, so in the previous video we have added double the size of our vector, as we said that the vectors are dynamic arrays. And you're going to see here that we have started with our zero size vector. We added 20 elements. We've seen here our elements. Then we added another 20, and we've seen here our elements again, 20 elements. So all up, because our element starts from 0, that's why we can see 39, but it's actually 40 elements. Alright, so in this video we're going to see further. We're going to see how we're going to pop the elements out of this, say here. I'm going to show you guys, say for example, if you want to pop 2, you can pop 2. If you want to pop 3, you can pop 3. You can pop any elements inside this our vector. Alright, so now we're gonna go here and check this one here. That's we said that the STL has 3 big components. The first one is container. I'm gonna remove this. The second component is iterator, and the third one is algorithms. Alright, so now if you look in here, to visualize this ones, I'm gonna make STL slides, and I'm going to show you guys through the slide. But before we start the slides, because I'm making the slides and then my slide is still halfway up and half complete. Now you guys will visualize this one like this is a container. We have another component which is algorithms, and there is iterators. So the iterator plays a key role between container and algorithms, and you can hear there is a container, and there is a container, and there is algorithms here. So there is a container, and our vector belongs to this component in STL, which is container, and we have another component, STL components called iterators, and the next one is gonna be algorithms. Okay, so as we said that the container is simply an object that contains other objects, and containers are used to manage, say for example, collection of objects of a certain type. What is certain type is because container is as we said is homogeneous. If all objects are the same type, otherwise it's heterogeneous. And the next one is the component is iterators, and iterators, as you guys going to see here, there is a for loop because for loop it iterates through, it goes element by elements, because we have put here we have put a number, so it iterates through the elements, each element by, and this is called iterators in the STL. And as iterators are used to step through the elements of collection of objects. So there is a collection. If you see here, there is a collection, and there is elements in between. So iterator goes through elements by elements. These collections may be containers or subsets of containers. And this is, as I said, it's a vector, and vector belongs to the container, sequence container in STL. And the next one is algorithms. Algorithms are used to process elements of collections. Say here, say the last one, guys, here, algorithms. Say as I said, the algorithms are used to process the elements of collection. So for example, we have a lot of algorithms like a search in C++. and every other programming language. You guys just type search, and it's going to search for you like a sort, modify like a string. You're going to find the first element inside the string, or last element inside this string, things like that. They're all algorithms in C++. And inside the first, because we are learning vector, the vector container contains the sequence container, associative container, and ordered containers, because now you guys should be easy to digest all this. So we have sequence containers, and we have associative containers, and we have unordered containers. Okay, so now this guy is here, the sequence container, the vector belongs to this class. So the vector, and there's going to be array, but don't confuse with the vector and the array, because this is different array. This is a class array. Then the next guy is going to be double ended queue, our deck, our some guys pronounces a heck, our is deck, because double ended q. So we're gonna explain to you guys in future videos about the deck. And we have the next one's gonna be list, and this guy is gonna be forward list. Forward list. Why we have a list and forward list? Because the list, the iterator moves in both directions, so it moves forward and it moves backward. We have a forward list, as the name suggests, because it moves only in one direction, so you guys can have two. And we have associative container. In the associative container, it has a set, our multi-set. It has a set, our say multi-set. Then it has a map and multi-map. So it has a map and it has a multi-map. And the last one's unordered containers. As you guys going to see here, is unordered set multi-set. Unordered set multi-set, and it's going to be an order map multi-map. So an order map and our multi-map. And sequence containers, as you guys going to see here, this guy is here, are order collection in which every element has a certain positions, as we've seen in the case of vector. We're going to see here all the positions in inside the vector, because all the elements have a certain position, and it depends on a lot of other factors. Say for example, it depends on the time and place of insertion. Then you guys are going to be looking for the next one is going to be associative containers, or sorted collections in which position of that element depends on its value. So for example, if you guys heard of associative arrays in PHP, that's exactly the one, because we have in Python we have a set and we had a map. You can see his multi-set, our multi-map. And the next one is going to be unordered or associative containers, are an ordered collection in which the position of an element doesn't matter. So here the position of element does matter in this guys here. So if you guys looking here, that's quite opposite, because a set is a multi-set, is an order set and a multi-set. You guys are going to see here that only this one doesn't have an order, this one have an order, because as the name suggests, is unordered containers. Or you can save unordered or unordered associative containers. Unordered associative containers, you can say it this way as well. And here you guys just like this one is like a bag of groceries. You go at the stores, you guys just don't pick anything, you guys just pick a lot. But this one, the order does matter. You guys can do this one with the set and multi-set and map and multi-map. You guys can do this, but with an order, you guys just like a bag of groceries. You go at the shopping center, you guys fill up your bag. It means you guys put every object there. You just don't put one object. And the order, it doesn't matter. You know, it's not in order. So now we're gonna go to our main topic, which we say how we're gonna remove say element from our vector here. Say for example, if I want to remove this 39, for example, I can do so. All I need to do is come in and put a pop back. So it means push and pop. If you guys heard the phrase in C++ is push, where we push elements inside the say stack, for example, and pop, push and pop, where we remove from stack, for example. So it's a push and pop. The first one is that we're going to push to the back. Now we have used push the back. What do we mean by push the back? And if you guys look in here, we have done our first ones is all the way to 19 here to 19, and we have pushed it to the back of the queue. Once we get to the stacks and queues, then you guys gonna have a lot of sense. This is gonna make a lot of sense to you guys, because now you guys gonna look here, because we have entered like 20 elements here before, and there's 20 element makes it 40 because we pushed it to the back. And I've learned C++ back in 1995 97, and that used to be very, very scary at that time. And I'm going to explain to you guys a lot of things that we used to do, but nowadays all the people inside the C++, it has grown and matured, and they're very simplified. So all the STLs now is very simplified, very concise, and everyone understand, easy to understand. But back then it was very, very scary, and the process that we used to do was scary. Okay, so now here, and keep in mind I learned C++ as a very, very young age. So I'm not going to mention my age when I learned, but I learned at a very, very young age. Okay, so here you guys gonna look at here that we have put another elements here. So how we gonna say pop, for example, elements from the back of this here C++. So for example, if you're gonna want to pop 2, or you want to pop 1, we're gonna do 1 now, and we're gonna see how we're gonna pop. And now we're gonna see we put X here, which because we have an X here. If you guys looking on top, we have X push back because we pushed through our iterator, our for loop. You're gonna see here for loop, we pushed like 20 elements, and now we're gonna put a pop, for example. So how we're gonna pop? We're gonna put for example X dot pop back, and you're gonna see what we're gonna pop back. We're gonna pop back 1 elements from the back. And if you want to see the size, you can see the size, for example. Then we're going to come and say, for example, here we're going to check the size of the vector now, and we're going to put it here because we pop 1, and we're going to see the size now. And we had say 40. Now the size is 1 less. Now we have the size is 39, while before the size was 40 because from 0. So now if you want to see the elements, for example, display elements, we can copy the whole here to see the elements, because we want to see which one of them's got popped out. And you're going to see here that we're going to see which ones here. You're going to see here we don't have a 39 now. We have a 37, but we don't have a 13. We have a, sorry, we have a 38, but we don't have a 39 here. So you go looking here, we have a 19, and it runs all the way to 39 from 0. And in this guys here, we don't have anything, because now we don't have a 40 elements because we pop 1 from the back. It's a pop back because now it's if you look in here, there is a big queue in front of the shopping center, and someone's number 39. It says, all right, I need to go because that's a stack, because the stack works like this. So there is something called LIFO in C++, which last in first out, like a stacks of the plates. If, for example, now you guys, if you're putting the number 1 plate, number 2 all the way on top of each other, so whoever is washing the plates, you're gonna remove the last one first, because it's last in first out, because number 39 was last in, and we remove it first out. So that's called it stacks in C++. Alright, so now we do this again. Say for example, now we're gonna see copy, and we're gonna see if you guys want to remove 2, we can do so. So we're gonna say, for example, run, and you're gonna see here now we don't have 2 from the end of our here, the end of our vector. And as you guys gonna see here is a dynamic array. We are we start, as I said, from 0. We have added 20 elements. Here is 20. We have added another 20, makes it 40, and here we have total is 40 elements whatever, and now here the size is not 40 anymore, it's a 38. And if you look in the elements, we are keep deducting from the elements here. So now looking here, our here vector is shrinking. It's not growing, but it's shrinking because we are popping elements from the back of the vector. Alright guys, so that's it for this video. I want you guys to understand the push and pop, and we're gonna follow this here, because now you guys are got involved in C++. We have 3 components, and we have container, iterator, and algorithms, and iterator plays a very key role in between the container and the algorithms. And in the container we have here we have a sequence container, associative container, and an order container. And first thing we are looking for a vector, then we're looking for a class array. Keep in mind this is not the simple array that you guys looking for. Then we have a deck, and we have a list, and we have a forward list. The list moves in both directions, and the forward list moves in just a forward direction. Keep in mind when we get to the iterators, then we're going to explain iterators, how the iterator works. And algorithms very easy, because you guys know algorithms just like normally automatically created algorithms. Like we can apply search, we can apply other algorithms, say for example for finding the first element or the last element, our sort, our we can see insert. Alright guys, that's it for this video. Thanks for watching, and don't forget to subscribe, Cryowood. If you guys have any question or comment, leave in comment box. Otherwise I'll see you guys in the next video, and bye.